This week we'll be discussing Chapter 3, and for the first part of the lecture set, we'll be talking about variables and the three types of claims that you're likely to come across when looking through research or conducting your own. So probably the most basic fundamental unit that one should be aware of are variables. Variables are any attribute that varies and has at least two possible levels. So it could be anything from they are either big dogs and small dogs, and that could be just the two different levels that I have of types of dogs, big ones and small ones, or I could divide all dogs into their requisite species, in which case each species of dog would be a different level of the variable what type of dog, or dogness, or however you wanted to talk about that. And so ultimately it can be either just two, big, small, or it can be many. For example, a continuous variable that has almost infinite possible levels would be how tall people are. And while human beings are only within such a range of height, many people have very slightly different heights. Someone could be 6'3", someone could be 6'3" and a little bit, and someone could be 6'3" and a little bit more, and someone could be 5'2", and someone could be just shy of 5'2", and so on and so forth. A lot of times we'll just simplify our life and say that people are, 5 foot tall something, 6 foot tall something, or slightly smaller gradations. And one of the important parts of learning ultimately how to measure these types of things is knowing how much accuracy and precision is actually required. But that's oftentimes something we deal more on the statistics side of, though it is important to keep in mind even from a methodological point of view. Some further distinctions when talking about variables. There are measured and manipulated variables, which are very much like they sound. Measured variables are just variables that we are measuring or recording in the purposes of acquiring information. So if I wanted to know how tall people were, I would put them next to a wall with a ruler and I would record how tall they were. Manipulated variables, on the other hand, are variables that we as the experimenters oftentimes are manipulating to see their effect on other variables. So for example, if I wanted to see if physical exercise made a difference in appetite, I could take half of my individuals and have them run 5 miles and the other half play the equivalent time of video games sitting on a couch and then look at how much pasta they ate. In this example, the manipulated variable would be the degree of exercise I made people take part in. So one set went running and the other set just sat on a couch playing video games. And those are now my two levels of exercise, and I'm looking at how that impacts how much they're going to eat. And in that case, the amount that they eat is my measured variable that I'm now just recording. Roughly parallel are dependent and independent variables. So a dependent variable in an experimental context is just the variable that we're measuring. And in a regression context, it is the outcome or criterion variable that we're interested in ultimately predicting or understanding more about. Experiments will fit much more with causal claims, and regression ultimately with association-based claims. We'll talk more about the types of claims in just a few slides. Getting into the actual statistics is not really going to be covered in this class. On the other side are independent variables, and those are the variables ultimately that we are interested in manipulating. So in an experimental context, like I described with the people who are running or playing video games, here it is the variable that is manipulated. But in a multiple regression context, this is ultimately the predictor variable that gets used. So if we're interested in being able to predict people's behavior based on the category that they themselves are in, that would then fall under the predictor variable. Even though you will sometimes hear it talked about interchangeably with independent variable, just be aware that oftentimes, depending on the type of experiments or research field that people tend to be in, they will use one set of language versus another. So it can be an indicator of what type of background people have, but at the end of the day, many of these concepts are hugely overlapping and so do tend to get used interchangeably. Just be aware that oftentimes it's their context that gives them their different names. Now, not all variables can be manipulated. So some it is just currently impossible to manipulate. For example, we could not assign people to live on different planets to test for the differential effects of gravity on our physiology. We currently do not have the technology to establish colonies on lots of different planets and just send people there willy-nilly because we would like to do an experiment on how them living on different planets would affect our bodies. Maybe one day in the future this will be something that is possible, but currently we do not have the capability to manipulate such a variable. Other variables could technically be manipulated, but it would be unethical to do so, and so those technically fall under this class of variables that cannot be manipulated. So for example, one cannot irradiate people with the goal of testing to see if junk food would make radiation sickness worse. This would just be completely unethical because at the end of the day, if you largely irradiated people, they're ultimately going to die, and you cannot just kill people for the sake of something as arbitrary as checking to see if junk food would make that end of their life even worse. In such a case, this would just be unethical. Now, this is largely as a joke, but at the end of the day, there are many types of things like this that are, one, just very difficult. For example, you could not willfully give people some type of medication, let's say, that is known to have awful side effects or something to this effect. Or if you were going to deprive people of food or children of affection or those types of things. Again, while technically possible, they would be unethical to do so. Now, there is some degree of a gray line that will occasionally come up, and when we next week start talking about ethics, we will talk a little bit more about how people make that sort of evaluation. For example, there were some studies to speed up the vaccine development where they actually infected people with the coronavirus to see how resistant they were after they had gotten their vaccine shots. Now, in this case, it is a delicate balance between the harm that you are doing to these people by ultimately infecting them with a potentially deadly virus to the potential gains that could be reaped by dramatically speeding up the implementation of a vaccine and thus saving many, many lives. And so while it is easy to say some things are unethical to manipulate, in real life it is not a clean distinction between yes and no, but rather there are things that are no problem to manipulate, other things that we would not even think about, but then there is this zone in the middle that it becomes a little bit more tricky and depends on the context. Now, when we're talking about variables versus actually measuring variables, there is a distinction in how we talk about them. So conceptual variables are how we ultimately talk about variables, and these are stated at some abstract level. Another way of referring to this, just to know, is either as a construct or as the conceptual definition of a variable. Now, oftentimes this is just how we speak about it or write about it or even sometimes think about it, but it is very difficult to measure in this format. So for example, we can talk about depression and we can talk about anxiety and we can talk about happiness, but many of these are actually, despite having very real ramifications on everyday life, relatively abstract concepts. And how do you measure something that is as abstract as that, let alone have a unified way of measuring something? This is where operationalization or operational variables come in. And this is the specific way in which a conceptual variable is either measured or manipulated in a specific study. Now, you can have a similar operationalization across many studies, but you could also have many studies all studying the same conceptual variable that have different operationalizations of how they measured it. You'll also hear operational variables referred to as operationalizations, operationalization of variables, and the operational definition of a variable. Excuse me. So a concrete example of this is that at a conceptual level, prejudice is often thought of as a hostile or negative attitude towards people in a distinguishable group based solely on their group membership. Now, it's a fairly large field in psychology that studies prejudice, and in that field or subfield, let's say, there are two primary camps. Even though they're not fully at odds with each other, it does ultimately line up kind of like this. And there are people who use two different ways of measuring or evaluating prejudice. Their operationalizations are different. Now, people who fall in the implicit measure camp, so these are people who use the IAT, the implicit association test, and they evaluate prejudice by examining the subconscious relationships that people have. Do I automatically slightly bias one class of people over another? Counter to this are people who follow the explicit measures operationalization. And to them, the idea is that just because people have negative associations about a group doesn't mean that they are necessarily going to be prejudiced. And so the only way to evaluate that is to actually either ask them or look at their behaviors to see if they operate in this way. Now, is one right and one wrong? No, they actually give us different pieces of information. Something much more curious is the lack of relationship between the two measures, which provides additional information, but that is beyond the purview of this class. Really what this is for is to show that prejudice has this notion, this definition and way in which we can talk about it, but then how we measure it is ultimately more difficult and nuanced and will depend on who is measuring it. So one conceptual variable can have many different types of operationalizations. And what types of operationalizations people use can make a dramatic impact on the type of conclusions and claims that they will make. Another huge part of ultimately any kind of research methodology or design is learning to operationalize variables in an effective manner. Moving on to the types of claims that you will find in empirical science. So the first are frequency claims, and these are claims that describe any type of particular rate, number, or degree of some single variable. You could hypothetically have frequency claims that are about multiple variables all presented at once, but please know that even when they're all presented at once, technically it is specific to each individual variable, even though they're presented together. Following this, we have association or relational claims, and these are claims about two or ultimately more variables in which the value or level of one variable is said to vary systematically with the value of another variable. Finally, we have causal claims, and these are claims arguing that a specific change in one variable is responsible for influencing the value of another variable. Now, these two are quite close, causal and association claims, but they have some specific and nuanced differences that are very important to keep in mind, because oftentimes when discussing research, people will talk about something that has association claims in it, and will speak about it in causal language or terms, which can be problematic. Now, some examples of frequency claims. So one person in the United States dies every 36 seconds from cardiovascular disease, right? This is just one per unit time. Another way of talking about this would be that is approximately 877,000 people a year. That would be just another way of discussing the same frequency. Just note that all we did is change the units of time here. Another frequency claim example would be 4 of the 8 planets in our solar system are terrestrial planets, meaning that they have solid ground upon which you could stand on. And finally, another one would be about 3.3%, or about 3 in every 100 people of the global population lives in a country other than the one in which they were born. Notice all of these are ultimately talking about how many of a certain type are either this, there, here, something to that effect. And note that in each of these claims, we can talk about one specific quality. The number of people who are dying because of a specific disease, the number of planets that are a certain way, the number of all human beings on this planet who live somewhere other than where they were born. Moving into association claims, these are oftentimes looking at the relationship between two or more variables. So a common example of this is that people's height and weight are associated or related. This would be an example of a positive association, as the taller one is, the heavier they tend to be, and the shorter one is, the lighter they tend to be. Now, does this mean that every person who is tall has to be heavy? No. It is just there is a general trend that exists where as people are taller, they tend to be heavier, and as people are shorter, they tend to be lighter. Another example would be job stress is negatively related to sleep quality, and this would be an example of a negative association, such that the higher one's job stress is, the worse their quality of sleep is likely to be, and vice versa. Finally, an example of a null association or a zero association is how often you go out with wet hair and how often you get the flu. These two things are actually not related because wet hair doesn't actually give you viruses, and you need a virus to get the flu. Now, also please note, because this is very important, and this is true of all association claims, is that these can all be stated in the reverse as well. So I said people's height and weight. So as people's height increases, their weight tends to increase. We can say it the other way around. As people whose weight tends to increase, we tend to see them as also being taller. As sleep quality declines, so too does job stress increase. And then for the null association one, you could say that in either direction, of course, just like the others, but here there is no relationship. How often you get the flu is not related to how often you go out with wet hair, and how often you go out with wet hair is not related to how often you get the flu. Please note that the directionality does not matter here because there is no causal implication. All we're talking about is two things are related. If you're going to get a scoop of chocolate ice cream and a scoop of peanut butter ice cream, it doesn't really matter which scoop you put into the bowl first. Your bowl will still have one scoop of chocolate and one scoop of peanut butter. A way to evaluate association claims is to do it visually using scatter plots. So here is an example of a scatter plot. You can also look at this in your textbook. You'll note that it is almost always on an X and then Y axis. For this example here, we have on our X axis the amount of expressed gratitude, and on our Y axis the relationship of longevity. So how long people are able to stay in a relationship, and we're looking at how much gratitude they tend to express with their partners in said relationship. And here you can see that if we were to try and draw a line that best captures this information, that line would probably be something like from here going kind of along this way. And you can see that that line tends to increase, such that the amount of expressed gratitude, as it increases, so too does it seem like relationships tend to last longer. And as the amount of expressed gratitude is lower, so too is the duration of those relationships. Now remember, just like I previously mentioned, this could be stated in the reverse as well. For example, people who tend to have longer relationships also tend to express much more gratitude in said relationships. So here would be an example of a positive association. Both things increase or decrease together. Conversely, looking at a negative relationship, here you can see that if I was to draw a sort of line that best captures the data, it would probably be something like that, where now it is going from the top left to the bottom right. And here on the x-axis, we have the frequency with which people multitask, and on the y-axis, the skill at which people are able to multitask. Now, here what we're seeing is as people tend to multitask more and more, their skill at multitasking tends to decrease over this increase, and vice versa. As people have higher and higher skill with multitasking, they tend to multitask less and less. So here would be an example of a negative association, because as one variable increases, the other variable tends to decrease. Finally, looking at a zero association, or something that's very close. So here you could technically draw a line in almost any of the directions. Hence, this is not related, where any movement on the time of dinner that people have does not indicate whether a child will be more or less obese, such that there are children who are high and low in obesity who have early dinners, just like there are children who are low and high in obesity when they have late dinners. And so this would be an example of a situation where two variables are not, or very loosely at best, related. You can see this represented by this sort of cloud of gnats that you see here with all of the dots. And just in case it wasn't clear, each of these dots represents an individual who is being measured. So this is one child who is low on obesity and eats early dinners. Now, scatter plots are great for quickly looking at a set of data and deciding whether there is a relationship or not, but they're not very specific or exact. In order to have more exact representations of a relationship, we use something called a correlation coefficient. Now, you'll see this oftentimes denoted by the symbol R. It will be small and italicized. it is bounded between -1 and 1. There cannot be correlation coefficients that are less than -1 or greater than 1. The sign of a correlation coefficient indicates the association, the type of it. So any negative correlation coefficient indicates a negative association, such that as one thing increases, the other decreases. And any positive correlation coefficient represents a positive association or relationship, such that as one increases, the other does as well. The magnitude indicates the strength of the relationship, such that the closer one is to 0, the weaker that relationship is, and the more the scatter plot will look like that cloud of gnats or the third drawing that we showed. The closer it is to 1 or -1, the stronger the relationship is. Now, something that oftentimes can throw people off is a correlation of 0.9 has the same strength as a correlation of -0.9. The only difference there is the direction of the relationship, not the strength of said relationship. So when evaluating strength, you will not look at the sign and only at the magnitude of the number. Now, one of the most useful and widely used qualities of association claims is the ability to use that information to then make predictions about other sets of information. For example, if we do know the actual correlation coefficient between height and weight, then if you were to give me information about another person's weight, we could use that information to predict their height. We could do the opposite as well, where you could then give us the information about somebody's height and ask us to predict their weight. And ultimately, the statistics behind these types of claims allows us to make these types of predictions, and in some cases, incredibly accurately. Now, the closer the correlation coefficient is to 1 or -1, ultimately the stronger that correlation is, the better our predictions will be, or rather the less error that they will contain, even though unless you have a correlation of exactly 1 or -1, there will always be some error, and in real life you are exceedingly unlikely to ever come across a correlation that is exactly 1, -1, or 0 for that matter. Now, correlations that are close to 0 do not ultimately allow us to make predictions. Or more specifically, because you could mathematically do it, is just that it would then have basically no meaning because there would be so much error in it that those predictions would ultimately not be worth it. Finally, we have causal claims. So these claims go beyond association claims by stating that not only are two variables related, but they are also causally linked to one another. Now, that is to say that one variable causes the other. Now, in order for a causal claim to be a causal claim, three things are fundamental. Now, the first is that there must be a relationship between the two variables. If there is no relationship, then there can be no cause and effect between them. Any two things that are related by a cause and effect relationship must be related to each other, because one causes the other, and thus whenever it is present, so too is the other, and the other will be absent without the first one being present. The second is that the causal variable must precede the outcome variable. This is ultimately saying that an effect cannot come before the cause. And while this might sound as a simple and obvious thing, you would be surprised how often these types of mistakes can happen in research, especially when it becomes quite abstract and there are many variables involved. Finally, one must be able to rule out all other possible explanations for the relationship. Well, at least to the extent possible, and this is referred to as internal validity, which we'll talk about in the next lecture set for this chapter. So an example of this would be that, let's say that whenever I go to see a friend when they're not feeling well to cook them chicken noodle soup to help them feel better, and they also always feel better after I take them chicken noodle soup. But it just so happens that every single time that I go over to cook them chicken noodle soup, I also take a cat that I allow the friend to sit and cuddle with and pet while I'm cooking the soup. Now, it could well be that it is the soup that is making them feel better, but it is also possible that it actually has nothing to do with the soup, and it is the fact that they get to cuddle with the cat for a little while that helps them make them feel better. Or maybe it's not the soup or the cat at all, but the fact that they know they have a friend who will come and make them some soup. Now, all three of those are possible explanations for why my friend is now feeling better. So, at the end of the day, I am not able to make the causal claim saying that it is my soup that is causing them to get better, because there are two other possible explanations for their recovery as well. The more and more in which these possible solutions or explanations are ruled out is ultimately a goal of having higher and higher internal validity. Finally, a little bit about causal claims in language. So when looking at how human beings talk about the world, we talk to each other or talk about stuff, we oftentimes talk about them in causal language, that this led to that, this led to something else, and it is ultimately how we tend to make sense of the world, and this is why we talk about it like this so much. This is something that is exceedingly common in news headlines and marketing promotions. That being said, please be very careful when reading such claims or watching them or whatever, because many times they're not actually justified. It will happen a lot that one will find a relationship between two variables, and then when one is reporting it to sort of a wider audience, that claim will get morphed into causal language, even though there is no established causal relationship. Finally, another place that one tends to see a lot of causal claims in language, though it's less strictly taken, is in advice. Whenever we're giving advice to one another, ultimately what we're doing is making causal claims. If you do this, then that will happen. But it is not often, not always, I don't know, your mileage may vary on that. It is unclear how much of the time advice that one person gives another is actually grounded in empirical support. And so even that, without making, your loved and cherished ones feel silly for giving you advice and you're like, well, no, that's not supported, so I think you're stupid, it's probably not going to go over so well at family dinners. But just be aware that it's always good to double check information, even when it's coming from close sources that you don't want to hurt their feelings. Last, not all claims are empirical. So not all claims that you'll come across will fit into the three categories that we talked about frequency, association, and causal. And they ultimately then do not count or classify as empirical, and we will not tend to use them very much in sort of overall research. Now, for example, there are single subject case studies, which do tend to get reported on, but one cannot generalize beyond this. Just because one person had some type of anomalous effect does not mean that can now be made into some type of claim, because you only have one of them. There's no relationship that exists here. There's no one out of how many. It is just a novel anomaly that exists, and thus those types of claims are not relevant here. Another type where this comes up a lot, where people make claims, is based on their personal or subjective experiences that either they themselves have had or that they know from others. These can be great fun to talk about. They can be wonderful philosophical discussions if you're so inclined, or they can just be food for hate and bigotry that is spewed at one another. But please remember that these ultimately do not classify as empirical claims, because they're just things that we believe or think one way or another and have not gone through this rigorous process.